Hello, good afternoon to everyone. We are going to see a new term in photochemistry, and that is quantum yield or quantum efficiency. And when we talk about this particular term, that time we have to go back to the Stark-Einstein law of photochemical equivalence, in which we have seen that how one molecule is absorbing one photon of light and how that accelerated molecule is responsible for the photochemical change. And in that, in short, we just say that one molecule, one photon. That means here we have to say that how one molecule gets dissociated or reacted or formed by absorbing one photon of light. So that particular relationship, 1:1 relationship between them, we define or we express in terms of quantum yield or quantum efficiency. And here, when we talk about this quantum yield, that time we say that this term is being represented by the symbol phi. And when we talk about the definition of it, that time we say that it is only the ratio of the number of molecules reacted or formed or dissociated with the number of photons absorbed in the given time interval. And depending upon this 1:1 relationship, we have to go again little further, and we have to discuss that the types of it, or which are the types of it that we have to see. So the three types of quantum yield can be seen here in a photochemical reaction. For example, here if you talk about, now here when we say quantum yield, that means we are just talking about how one molecule gets reacted or formed or dissociated by absorbing one photon of light. So that time we say that the quantum yield is equal to 1 of such photochemical reaction. Then in the second part, if we say that phi, that is the quantum yield, is greater than 1, that time we say that by absorbing one photon of light, more than one molecule may get dissociated or reacted or formed. And in such case, we say that the value of this phi or the value of this quantum yield is greater than 1. So in such case, or such photochemical reaction are said to have high quantum yield. And the third case, if the quantum yield is less than 1. So in that case, we are observing that less than one molecule is reacted or formed or dissociated by absorbing one photon of light. So depending upon this, we are saying that which photochemical reactions are said to have high quantum yield. And here we say that when the quantum yield of such reaction is greater than 1, that time such photochemical reactions are said to have high quantum yield. Then the second part, which reactions, photochemical reactions are said to have less quantum yield or low quantum yield. And here we say that when less than one molecule is reacted or formed or dissociated by absorbing one photon of light, such photochemical reactions are referred or are said to have low quantum yield. So in this way we are categorizing them, and so in this way we say that that may be two yields or two high quantum yield and low quantum yield reaction may be observed. And again, one more point which is very important in the photochemical reaction is that chemical reaction may occur or may have two types. Number one, for example, A is the reactant which is absorbing one photon of light, that is we represent as H nu, that gives the excited molecule A. So this first reaction refers the primary reaction. Then the second reaction, and the excited molecule A gives the product. So that second reaction we call it as the secondary reaction. So we have to remember this, that whenever we talk about the photochemical reaction, there may be two types. The very first reaction, in which the molecule or the reactant may be absorbing the light in the form of photon, is the primary reaction. And the very second step reaction, or the reaction which is subsequent or which is immediately followed by the primary reaction, that reactions are referred to be secondary reactions. So in this way we have just covered 2 points here. One was quantum yield. In that we have seen that which photochemical reactions are referred to be to have high quantum yield, and which photochemical reactions are having low quantum yield, and number second, the types of each. Number one, primary reaction, and the second reaction. So with this we will stop here only, and we will continue the remaining part tomorrow.